Good day, dear colleagues. I'm pleasure to present to you the work named Augmented Reality Audio Stream Creation using CNN, boosting inclusion and safety for visual impaired people. According to the World Health Organization, there are about 2.2 billion people with visual impairments in the world. The main problems are difficulties with mobility, insufficient accessibility of the urban environment, limitation in the perception of information, and difficulties in social interaction. The development of new technologies will contribute to increasing inclusion and safety for people with visual impairments and creating an environment that takes into account the needs of people with disabilities. And the creating software will contribute to the achievement of the Sustainable Development Goals, in particular CDG number 3, 10, 11. Research goal is to boost the inclusion and safety of visual impaired people by creation an audio stream of object and named person indefinite and classified from a video stream using convolutional neural network. The main paper contribution is the proposed method of augmented reality audio stream creation using CNN, which differs from existing ones is in the when classifying object in a video stream, it's able to recognize named person among them, which contributes to increasing the level of inclusion. Figure proposed a general approach to converting input information in the form of a video stream and a prerequisite list of dangerous objects for people with visual impairments into output information in the form of audio stream. In accordance with the presented approach in previous figure, a diagram of the method of augmented reality audio stream creation using CNN is shown in figure. As part of the conducted research, the use of YOLO models for identification and classification of objects from the video stream and CNN for classification of named person is proposed. The method proposed the video stream using neural network models to identify objects and classify named persons. The process begins with processing the video stream to prepare it for object detection. The identified objects are classified, filtered based on a confidence threshold, and if a person is detected, processed of face recognition. Named persons are classified by detection facial boundaries and calculation confidence scores. The system then generates audio output pre-reason dangerous object for a voice-over. To classify a named person detected in a frame from a video stream, a cascade-based classifier detects the face boundaries with the bounding box provided by YOLO. If no face is detected, classification of named person is skipped, and only the word person is announced in the audio output. If a face is detected, a CNN model classifies the person and the output the name of the person. To test the presented method, it is necessary to study the existing pre-trained YOLO models, as well as to investigate the influence of the batch size and the number of epochs when training the CNN model of the accuracy of the classification of named persons. In the process of experimental research, test software was created for creation an augmented reality audio stream. To study the models, the COCOSET dataset was used. To study of the object classification at stage 2 of development method, the YOLO models were compared, which are pre-trained to classify environment objects. The models were compared using the metric accuracy, precision, recall, etc. Figure shows the result of calculated macrometrics. As can be seen from figure, the YOLO 11X model demonstrates above average prediction accuracy for each class, but for some classes such as bicycle and traffic light, it demonstrates lower values than for other classes, which is associated with the complexity of their detection. As part of the study, FPS was calculated for models, which allows us to assess the stability for real-time application. The model were tested on a same video containing scenes with people and cars. The result of FPS calculations are presented in table. The best results are shown by YOLO 11X. For the classification of named persons, the CNN model was trained to identify 90 named persons, and a separate class was other, in which photos of different persons were mixed, which were taken in the amount of 50 photos from the open source dataset. According to the result presented in table, the optimal values of batch size are 32 and number of epochs is 10. Since which these parameters, the highest classification accuracy of 97% is achieved. The result of the CNN model for the classification of named person demonstrates high accuracy. In particular, the micromatrix accuracy, precision recalled, and F1 score indicate sufficient accuracy and completeness of recognition for each class. The CNN model's limitations include reduced confidence in classifying named person when the face is at a 3/4 angle, or in profile due to insufficient recognition features. Glasses and masks lower classification accuracy, while hedge does not. Another limitation is the lack of distance measuring algorithm, leading to difficulties in correctly identified objects and that are too close or far. Perspective distortion can cause mystification or omission, especially for distance objects like cars. For named person classification accuracy heavily depends on face quality and size in the frame. Approach for boost the inclusion and safety of visual impaired people by creation method of augmented reality audio stream is proposed, which creation which contains object and named persons identified and classified from a video stream using CNN. Development method differs from existing one by two advantages: ability to classify named person in the video stream for boosting the inclusion for visual impaired people, and ability to consider of pretty dangerous object when generating audio stream for boosting the safety of visual impaired people. By this method is contribute to achieved CDGs number 3, 10, and 11. Obtain the applet comparison result of neural network models reviewed that the YOLO 11X model is better suited for objects identification and classification in environment. Obtained the applet results from CNN model. Macrometrics indicate high quality classification of named persons. Thank you for your attention.